Good morning, students. Today we are going to see introduction and applications of digital image processing. In digital world, one picture is worth more than 10,000 words. So we can get more information from picture. So in this video we can get what is digital image processing, then what is a digital image history, then some applications of digital image processing. What is digital image? So a digital image is a representation of a two-dimensional image as a finite set of digital values, that is zeros and ones, called picture elements or pixels. So pixel values typically represent gray values, colors, heights and opacities, etc. So the digitization implies that the digital image is an approximation of an real image. So this is our real image. So while you are storing this image as a digital image, it's stored like this only. So common image formats include 1 sample per point, 3 samples per point and 4 samples per point. 1 sample per point means you can get it only black and white or grayscale values. Then 3 samples per point means you can store red, green and blue. 4 samples means red, green, blue and alpha values also. So what is digital image processing? Digital image processing focuses on two major tasks. The first one is the improvement of pictorial information for human interpretation. The second one is the processing of digital image for storage, transmission and representation for autonomous machine perception. So in some arguments about what is digital image processing and where the image processing ends and the fields such as image analysis and computer vision start. So the continuum from image processing to computer vision, it can be broken up into low processing, mid processing and high level processing. So what is low level processing means? You can give the input as image and also you can get output also image. For example, noise removal and image sharpening. Then mid-level processes means you can give input as image, then what will we get means that means output means that is attributes. Example, object recognition and segmentation. High level processes, that is you can give the input as attributes and output also you can get some information or understanding from the image. Example, scene understanding and autonomous navigation. Then we can see the history of digital image processing. In early 1920s, one of the first applications of digital imaging was in the newspaper industry. So this is what early digital image. So the Batlan cable picture transmission service. So the image were transformed by submarine cable between London and New York. So the pictures were coded for cable transfer and reconstructed at the receiving end on a telegraph printer. In mid to late 1920s, the improvements to the Batlan system resulted in high quality images. So the image will be very clear. So the new reproduction processes based on photographic techniques. The another one is it can increase the number of tones in reproduced images. So this is the improved version of this digital image. So in this picture, it contains early 15-tone digital image. Next, in 1960s, the computing technology and the onset of the space improvements lead to the surge of work in digital image processing. In 1964, the computers used to improve the quality of images of the moon taken by the Ranger 7 probe Such techniques were used in other space missions, including the Apollo landings. So this is what the picture taken by the Rangers 7 Pro minutes before landing. In 1970s, digital image processing begins to be used in medical applications. In 1979, Sir Godfrey N. Hounsfield and Professor Alan M. Cormack shared the Nobel Prize in Medicine for the invention of tomography. The technology behind computerized axial tomography scans are there. In 1980s, that is the use of today's digital image processing techniques has exploded, and they are now used for all kinds of tasks in all kinds of areas. So in so many areas are using this digital image processing. Image enhancement or restoration, artistic effects, medical visualization, industrial inspection, law enforcement, human computer interfaces. So one of the most common use of digital image processing techniques is used to improve the quality and removing the noise, etc. So this is this picture, so original picture. So if you are applying some techniques of digital image processing, then we can get this easily visualizing all the elements of an image. So here in this picture, noises are present. So after applying some techniques in this picture, the noises were removed. So in another one application, that is space, in space we are using digital image processing. So in 1990, the Hubble telescope was launched that can take images of very distinct objects. So however, an incorrect mirror made many of Hubble's images useless. So after image processing techniques were used, all the errors are rectified. So in artistic effects, where we use this application, it is used to make images more visually appealing, to add special effects, and to make composite images. So this is what we are using now in film industries. Medicine. So in medicines we are using so many techniques for radio frequencies, X-ray imaging, gamma ray imaging, magnetic resonance imaging. So these are all used to visualize the image in clarity. So we can know what is ultrasound. Here this is also used to visualize the data clearly. The next one is 3D tomography and rendering with the transparencies. So this is a human brain. We can get 128 cross sections. Then here this is cancer diagnosis the cancer cell. There is 256 cross sections. This is ice block image. In ice block, that is a human brain, 128 cryo sections. So the take slice from MRI scan of canine heart and find boundaries between types of tissues. The image with gray levels representing tissues density, it is used as suitable filter to highlight edges. So here you are using the edge detection techniques to detect the boundary of the dog heart. Then another one place we are using this geographic information systems, that is satellite imagery, terrain classifications, and meteorologies. And also we are using this DIP in industrial inspection, the human operators are expensive, slow and unreliable, so make machines do the job, same job instead of human. The industrial vision systems are used in all kinds of industry, but if we can trust means it is somewhat problem only. So the next area is printed circuit board inspection. So the machine inspection is used to determine that all components are present and that all solder joints are acceptable. So both the conventional imaging and X-ray imaging are used. So and also in law enforcement we can recognize the number plates of the vehicle. This image processing techniques are used extensively. In another one area, fingerprint recognitions, we can get all the differences of the fingerprints. Then another one area is HCI, that is human computer interfaces. So that is more natural, that is for face recognition and gesture recognition. So this is what we are using in all offices for entering into the organization. Thank you.